Let's open up our ScioBot 1.0 kit. Inside you'll find a couple bags with some plastic parts, electronic components, rubber bands, motors, some wooden craft sticks, AA batteries, and a card with build instructions. Taking a closer look at each bag, you'll see that this one has 2 rubber bands, a dual AA battery holder, a mini breadboard, and 2 geared mini DC motors. In the next bag we have 2 wheels, a ScioBot 1.0 T connector, 2 motor mounts, and a bracket to mount the AA battery holder. We will be using these 2 wooden sticks to build the main chassis of the ScioBot. And of course we can't forget about the 2 AA batteries that will act as the power source for the ScioBot. To build the main chassis, we'll need the 2 wooden sticks, the T connector, and the AA battery mount. Start by inserting one of the wooden sticks into the slots on the AA battery mount. You can slide it about halfway down for now. Next, do the same thing for the T connector. Make sure you're sliding the wooden stick through the slot that goes all the way through the T connector. And finally, attach the 2 parts together using the remaining slot on the T connector. For this step, we'll need the 2 wheels, 2 rubber bands, as well as the 2 motors and their motor mounts. Press each motor into a motor mount. They should slide in and fit snugly. Try your best to avoid pressing on the wire connections on the back of the motor to avoid damaging these connections. Now we need to locate the flat part on the motor shaft. We want to make sure to align this flat part with the flat part on the wheel when we insert the motor shaft to the wheel. Remember to be mindful of the wire connections. Now we can do the same thing for the second wheel. Let's give our ScioBot some traction by wrapping these rubber bands around the rim of the wheel. We are now ready to put the final touches on the assembly of the ScioBot and get it ready to wire up and run. Start by attaching the wheel assemblies to the main frame using the slots on the motor mounts. Make sure you push the stick all the way into the motor mount to prevent it from coming off. Place the mini breadboard into its slot on the T connector. Press the AA battery holder into its bracket. A quick lesson on the breadboard. Each pin in every row is connected, so anything you plug into a pin on a given row will be connected. However, every row is independent from the other rows. Let's start by saying the top row will be our positive and the bottom row will be our negative. Starting with the left motor, plug 1 lead into the top row and 1 lead into the bottom row. It doesn't matter which one goes where. A DC motor will spin in a direction depending on the polarity of the current applied. So with this configuration, the DC motors will spin one direction. If you switch the polarity of the input power source, the motors will spin in the opposite direction. Let's now plug the positive lead from our battery holder into the top row. Before plugging the negative lead into the bottom row, let's insert the batteries into the battery holder. When you plug the negative lead into the bottom row, your ScioBot will turn on. Depending on the polarity that you plug the motor leads into the breadboard, Your ScioBot might be dancing differently than mine. We can now play around with the configuration of the wiring to make the ScioBot behave in different ways. Try swapping the leads from one of the motors to see what happens. Visit nonscio.com for more information on electronics, programming, and robotics.